Let us look at a couple of examples of how energy moves between stores. Now, in the first example, here we have two magnets that have been pushed close together. In this case, both the magnets are facing each other with their north poles. Let us assume that there is a store of around 30 joules in the magnetic store, in the magnetic energy store. Now, as soon as these magnets are pushed close together, they will repel. And as they repel, they will be pushed apart. So what has happened here is that the energy store reduces to zero in each of the magnets, and it gets converted into kinetic energy store for the two magnets. So in this case, the total, so here we talked about the magnetic energy store, and then we have the kinetic energy store, so which will be zero in the first case. Now when they are pushed apart, the magnetic energy store becomes zero, and the kinetic energy, the energy in the kinetic energy store of the magnets is equal to 30 joules. What basically will happen is, because both of the magnets, they are exerting an equal push on each other, so both of them basically have 15 joules in their kinetic energy store. So this is just a small thing to keep in mind, because the energy store transfers into the kinetic energy store of the two magnets. The second example is that of a cell passing a charge through a lamp. The charge will flow through this circuit for a few minutes, and as a result of that, the chemical energy in the cell will decrease by a certain amount. Let us just assume that it is 100 joules. So this 100 joules of energy then is converted into the store of internal energy in the lamp and the surroundings. So what happens is, before the battery is connected, we had 100 joules in the chemical energy store of this battery, and after a few minutes, when the current is allowed to pass, we see that the chemical energy store in the battery reduces by 100 joules, and that 100 joules of energy is stored in the internal energy store of the bulb and passed on to the surrounding.